Hi friend, welcome to Math A to Z. Today we discuss method of undetermined coefficient from ordinary differential equation, that is from ODE. Now we all know that second order linear ordinary differential equation looks like d2y by dx2 plus p of x into dy dx plus q of x into y equal to r of x, and this is named as 1. Now we also know that the complete solution of the differential equation contains two parts. One part is denoted by yc and another part is denoted by yp, and this is called complementary function and this is called particular integral or particular solution. And adding these two parts, complementary function and particular integral, we get the complete solution of 1. Now, what is CF or complementary function? By taking r of x equal to 0, that is, if r of x equal to 0, then we get the equation 1 becomes like 2, and this is the homogeneous second order linear differential equation, and the solution of 2 is known as complementary function. And we know how to find complementary function of a differential equation. This is not our topic today. Okay. Now, if we take r of x in proper place, then we have to find the particular integral. Okay, and to find particular integral by method of undetermined coefficient. What is the working rule to find the particular integral by method of undetermined coefficient? Now I discuss all the rules, working rule of method of undetermined coefficient one by one. Okay, let us see. At first, if r of x equal to e to the power ax, if r of x equal to e to the power a of x, e to the power ax, then case A, if this A is not a root of the auxiliary equation, here auxiliary equation is m square plus p into m plus q equal to 0. If A is not a root of auxiliary equation, then yp, that is particular integral, is of the form a into e to the power ax, right? Case B, if a is a simple root of the auxiliary equation, then you can take yp is equal to ax e to the power ax when a is simple root. Similarly, if a is double root of auxiliary equation, then similarly we take yp as a x square e to the power x, and so on, right? Now we go to the second case. If r of x is of the form a0 plus a1x plus a2x square plus 2an x to the power n. Then we take particular solution yp is of the form a plus b x plus c x square plus 2m x to the power n. That is, the particular integral is also in this form, right? And in case if q of x equal to 0, that is, there is no term containing y, then the particular integral is changed and then is of the form yp equal to x into a plus bx plus cx square to m x to the power n, right? And similarly, if r of x is only a constant, then here yp is equal to only a constant. And here also, if this term is absent, then yp is equal to a into x, right? And also, if p of x and q of x both are 0, then this change to yp equal to x square into this, and this is also changed a into x square. Okay. Now go to the third case, case 3. If r of x is equal to sin a of x or cos a of x, okay, or sin a of x plus cos a of x is in this form. Okay, this is not taken. If r of x equal to sin a of x or cos a of x, then complementary function can be taken as yp equal to a cos a of x plus b sin a of x for both the case, sin x or cos x. Now, if sin a of x or cos a of x, any one of them or both, be in complementary function, right? Then yp is taken as x into a cos a of x plus b sin a of x, right? If sin a of x and cos a of x not containing c of x, then yp is of the form this. And if sin a of x or cos a of x or both contains in c of x, then we must take yp equal to x into a cos a of x plus a cos ax plus b sin ax, right? Now, in more complicated case, if r of x is of the form e to the power ax into cos bx or e to the power ax into a0 plus a1x plus an x to the power n, or sin bx into a0 plus a1x plus 2an x to the power n, then as in case 1, 2 and 3, we multiply the yp for this and this, and this multiplying both the yp, we get the modified yp for this r of x, and for similarly for this and similarly for this. Okay. Now these are the working rule of the process or of the method of undetermined coefficient. Now to explain how we use this method, we take a very important example, and this is, we take a complicated example to well explanation. Take y double dash plus 4y equal to x square sin 2x, right? And from this it is easy to write the complementary function as c1 cos 2x plus c2 sin 2x, right? This is yp, and yp contains sin 2x, so there is a complication, and x square and sin 2x are in the form of product. So by the method of undetermined coefficient, to solve this problem or to find the, this is yc, to find the yp, we can take the particular integral is of the form a0 or a plus bx plus cx square for this x square, and for this we have to let d cos 2x plus e sin 2x, and also we note that since sin 2x contains in the complementary function, so for sin 2x we take another x as a product in yp, that is, this is ax bx square cx cube, and if we multiply all two factor, we get the complementary function, we get particular integral is of the form a dash x cos 2x plus b dash x sin 2x. We take, this is a1, this is b1, plus a2 x square cos 2x plus b2 x square sin 2x plus a3 x cube cos 2x plus b3 x cube sin 2x, right? And this is the particular solution. Now we find yp dash and yp double dash, and since this is the solution of the equation 1, so we can write yp double dash plus 4 into yp equal to x square sin 2x. Now from this relation we find yp double dash, and this is also yp. Now putting this value of yp double dash and yp and equating the coefficient from both sides, we can find a1, a2, a3, b1, b2 and b3. Okay, so when we find a1, a2, a3, b1, b2, b3, then we completely find yp. Now the complete solution y is equal to yc plus y. Okay, this is the total method, and this is very important example to discuss the method of undetermined coefficient. Okay, this method is very important for WBCS main exam. Okay, and also important for M.Sc entrance and B.Sc course. Thank you for watching.